Okay, this is a rectangular plane, and this is my vector W. So now the initial point of this vector W is at the origin. Then the angle formed by this vector W and the positive x-axis, this guy, is called the direction angle. Okay, so the direction angle of W, this is the angle formed by vector W and the positive x-axis. And this angle is greater than or equal to 0, but less than the 360 degrees. Okay, so this is a non-negative angle greater than or equal to 0 and less than the 360 degrees. Now, suppose the magnitude of this vector W is R. So the magnitude of R, the magnitude of the W is equal to R. And then we can also, in this quotient 1, we can get the horizontal component and the vertical component of this W. So this guy here, this is the Wx, which is the horizontal component of W. And here, this is Wy, the vertical component of vector W. Now, let's look at the relationship between the magnitudes of the vector W and its horizontal and the vertical components. We know in this right triangle, we have the magnitude of the Wx equal to the length of this vector W times the cosine theta, right? So you have this guy R times cosine theta. Or you can see the magnitude of Wx over the magnitude of W, which is R, equal to cosine theta. And then we have the magnitude of Wy equal to R, this guy R, times sine theta, because Wy, okay, is the side opposite this theta, right? So you have R times sine theta. Actually, since right now we're talking about the length, the magnitude, we need to add the absolute value bars around this expression. Okay. And so is here. And then we can also have the magnitude of wy over the magnitude of w equal to the apps value of sine theta. Now, let's look at one example. Let's go to the page 611, and we look at the problem 14. It says, find the magnitude of the horizontal and the vertical components for each vector v with the given magnitude and the given direction angle theta. Okay, let's come back to the whiteboard. Let's go to the next page. So this is the page 611, problem 14. We have the magnitude of vector v equal to 6,000, and the direction angle is equal to 13.1 degrees. Then we need to find the magnitude of two components. So let's first get the horizontal components. So this guy, the magnitude of this horizontal component is equal to the magnitude of v times the apps value of cosine theta, and this is equal to 6,000 times cosine 13.1 degrees, and then this is approximately equal to 5843.86. And then the magnitude of the vertical component is equal to the magnitude of the vector v times the apps value of sine theta, and this is equal to 6,000 times sine 13.1 degrees, and this is approximately equal to 1359.91. And we can also talk about the component form of vector like this. So now let's talk about the component form of our vector. So if we put a vector into a rectangular plane with the initial point at the origin, say this is my vector v, then this vector is called the position vector or the radius vector. This guy is called the position vector, or say the radius vector. And suppose the coordinates of the terminal point of this vector is the A, B. So now we can use the coordinates of the terminal point of this vector to write out the component form of this vector v. So the vector v can be written as angle, left angle bracket, then first component of the terminal point, then second component of the terminal point, and then right angle bracket.